So welcome to this screencast. This one's all about a human pedigree, and there is several reasons why a pedigree is used instead of a Punnett square. So a genetic counselor will use a pedigree in order to trace different patterns of inheritance. So here in the first paragraph, we could highlight very easily that a pedigree, oh, I don't like that color, let's change that color, is a tool that we use to study patterns of inheritance. Ooh. All right, and it's going to trace the occurrence of a trait through generations of families. It's not going to matter if it's not in the bloodline, okay? And it can trace any kind of trait. So in general, we can look at many different specific things. So in this paragraph that we're going to look at next, right here, oops, that doesn't look good. Let me fix that. Gotta love technology. So in this paragraph right here, we are going to talk about something specific. We are going to look at what is called sex-linked disorders. So it goes on to say, pedigrees can be useful in tracing a special class of inherited disorders known as sex-linked disorders. Sex-linked disorders are associated with an allele on the sex chromosomes. We learned that there are 23 pair of chromosomes. All right, so there are 23 pair. Our 23rd pair is the XX chromosome. That one means girl. And we have the XY chromosome, and that is our boy. We should remember those from previous lessons. All right. Many sex-linked disorders, such as hemophilia and colorblindness, are found on our X chromosome. So you definitely need to know what hemophilia is. And that is not highlighter. So let's fix that. Go back to highlighter. Hemophilia and colorblindness, all right, they're going to be found on the allele that is the X chromosome. So let's talk about hemophilia for a second. Hemophilia is the one, that's this one right here, all right, that is the inability to have your blood clot, which means that if somebody has a cut, their blood is going to continue to flow and it doesn't stop. So it's as if its directions, or sentences, I should say, doesn't have a period at the ending. So it's just one big run-on forever. And so when its directions are constantly talking, it doesn't ever give the instructions for the blood to actually stop flowing. It doesn't have part of the directions to say the blood needs to form a bubble on the end and a scab needs to form. It doesn't have that instruction, so therefore the blood continues to flow out. That is a recessive trait. So it could look like lowercase h, lowercase h. So let me erase the screen here real quick. And we can look at a few other things. So that's hemophilia. That is going to be found on the lower part of the X chromosome. I'm going to demonstrate that by using colorblindness because that's the one that most people understand the best. You may know somebody who is colorblind. Maybe you don't, but most people know one person or two people who have colorblindness. So, as this sentence says, that a woman has two X chromosomes and a guy has one X chromosome. A woman who is heterozygous, right here, oops, I changed that again. A woman who is heterozygous for the trait of colorblindness is going to be known as a carrier. This is incredibly important, okay? because a carrier is somebody who we are going to say is a hybrid. Let me show you what I mean by the X chromosome and the Y chromosome and where the trait would be located. So let me draw an X chromosome and next to it a Y chromosome. The Y is not as long as the X chromosome. So this is going to represent a boy. Okay, so here is our boy. And I know I'm not necessarily great at writing the word on the computer. Okay, so let's designate the colorblindness trait right here by the blue mark. There is nothing on this part of the Y chromosome because it doesn't exist. So therefore, it cannot counteract it. So there is nothing there to counteract it. All right, so let's see how great I can do. Counteract. All right. Ooh, almost okay. So there's nothing there. So it can't. There we go. Isn't that under? That's pretty awesome right there. It can't counteract. All right. The Y chromosome can't counteract. So that means that here, no matter what, the boy is going to have the trait or not. So the boy will have the trait or won't have the trait. My ends need some work. Okay, so this is information that is very important. All right, so when you know, oh, that T is pretty bad. You can laugh at me all you want to, but maybe you'll remember it because visually you'll be like, wow, do you remember when she crossed that T? All right, so what is important right now? The important part is to remember this, okay? The Y can't counteract the X chromosome. So if I were to draw a female chromosome pair, and I have two X chromosomes, all right, I'm just going to label it with a G for girl. And let's say that she has the trait down here, okay? One, this is where she would be called a carrier, okay? Because if she only has one of the traits, or if she only has one trait on one of her allele, then this is when she is a hybrid and she does not have the trait, she only carries the trait. Let's say that she has it on the other one as well. So when she has two alleles, the second thing that she is she has the trait. So the girl can not have the trait where she's completely plain. She can carry the trait if she has it at a lower allele or at the lower part of the allele, or she can have the trait. So this is what happens. When somebody has this particular setting going on as a boy, this means that they are colorblind or has a sex-linked trait. So in this particular example, and we're going to go with colorblindness, I'm going to put CB for colorblindness, all right? Then this boy is colorblind because the trait is down here at the lower part of the X chromosome. There is nothing on the other side to counteract it. So this boy has the trait. If that boy was with an X allele and a Y allele and there was no trait that showed color blindness, then he would be completely normal vision. Now down here for the girl, I will draw what we had the first time was a plain girl with normal vision. All right, then here we have a girl who is a carrier of the trait, but she has normal vision. And over here we have a girl who then has color blindness. You could do the same thing for hemophilia, which is a sex-linked trait, or male pattern baldness, which is a sex-linked trait. So this is something that you would find on your X and Y chromosomes. And you can look up other kinds of sex-linked traits if you would want to. Quick example. My sister has normal color vision. My brother-in-law, who is married to my sister, he unfortunately is colorblind. All right. So he has the bottom of his X chromosome with that trait. So when we're dealing with a pedigree, we're going to show a line in between the two parents, and that means that they have been married. And then there's also a line that comes down. Now, we're going to do that with the chart at the bottom of page 142, but I just want to show you that these two are married. Now, they have 3 children, all right? They are all girls. So here is their oldest. Her name is Alden. Here is their middle child. Her name is Alexandra, and we call her Z. And then here's their last one. Her name is Eleanor, and we call her Ellie. So those are their 3 children. Now, when it comes to whether or not they are colorblind or not, we have to look at the alleles. So I'm going to change the color to blue or green just for a moment. They are going to get one of these 2 alleles from my sister. So it doesn't matter which one. They are not going to have a trait for color blindness. So it doesn't matter if it was the first allele or the second allele for either one of them. It's not going to have the trait. This is the only allele they can get from their father. If I look up, they're going to get the trait for color blindness. So that means, let's call this the side that was given to them from the father. All right. And I'm going to just make it blue across so therefore we can see it. Each of these girls have one of the alleles on their pair. So that means that each one of them is a carrier of the trait for color blindness. It does not automatically mean that their children are going to have color blindness, but there is a higher probability that the boys that they have could potentially have color blindness quicker than the girls. And the only reason for that is the girl could be a carrier because they could give this to their girls, right? But if they happen to give this one to their son, then they will also automatically give the trait to their son, just like that. If they have a girl, they could potentially give the normal color vision, or they could give the color blindness, but then it all depends on whether or not the person that they have a child with is colorblind or not. If the person that they're with is not colorblind, then their daughter will not be colorblind. She just may be a carrier. Not all traits on the